is chapter 7 on redox reactions, and we'll go over a few things to find the oxidation reduction and some few terms and solve half reaction. So what is a redox reaction? Typically, general equation or definition is that it gains oxygen. That's why it's called oxidation. That's an old term, really. We talked about this in class, but magnesium goes from not having oxygen to gaining oxygen. And then here you have copper has oxide and it loses oxygen, so it's being reduced. So copper oxide is being, well, copper is being reduced. So a basic definition is oxidation, but the key term, most importantly, is the actual charge of an atom. So you can see here iron goes from 3 plus to 2 plus, so it's being reduced. And iodine here is going from I minus to I2, which is a zero charge, so it's being oxidized because the charge goes up. So if the charge goes down, it's reduced. Charge goes up, it's oxidized. Few things to remember is Leo goes grr or oil rig. They're all terms that can help you determine if it's oxidation or reduction. So if it loses electrons, it's oxidized. If it gains electrons, it's reduced. Increase in oxidation number is oxidation, and decrease in oxidation number is reduction. So here we have an example. Tin goes from 0 to plus 4 because oxygen is minus 2 on SnO2. So tin has to go from plus 4, and therefore it's being oxidized because the charge is going up. Nitrogen goes from plus 5 to plus 4, so it's being reduced. Now the other term to help is oxidizing agent and reducing agent. So easy way to remember it, if you are being reduced, you are the oxidizing agent. You're the one causing the oxidation. If you are being oxidized, you are the reducing agent, so therefore you are the causing of the reduction. So they're opposites. So if you are, easy way to remember it is that if you are oxidized, you are the reducing agent. If you're reduced, you're the oxidizing agent. Now the agent isn't the atom, it's the actual compound it's coming from. So for example, in this one with nitric acid, HNO3, yes, nitrogen is being reduced, but the oxidizing agent is HNO3, nitric acid. Few things, just remember that if you're being oxidized, you are losing electrons, you are the reducing agent, and the oxidation number is increasing. You're being reduced, you're gaining electrons, you are the oxidizing agent, and therefore your oxidation number is being reduced. Here is a checkup question on the homework. You have to label which reagent is being oxidized and which one's being reduced, and then label the oxidizing agent and the reducing agent coming from that reactant. So what's actually happening? Why are these actually changing oxidation numbers? It's because they are losing and gaining electrons. So in this example, carbon dioxide is going from plus 4 to plus 2, so it's being reduced. It is losing electrons. Their electrons are going to be transferred to somewhere else, in this case to hydrogen, because hydrogen going from 0 to plus 1, so it's being oxidized. Alright, so what's happening in a chemical reaction? So to help separate the transfer electrons, they call half reaction. So basically you're cutting the reaction in half and using 2 reactions to make 1. So here's a typical reaction making salt, and you can see sodium half reaction is going from Na 0 charge to Na plus 1. So it is losing 1 electron. You can see that 1 electron in the product side. Where chlorine, so it's being oxidized. Chlorine, on the other hand, is going from a 0 charge to -1. so it's gaining electrons. Now it needs 2 electrons because there's 2 atoms of chlorine. So you have to balance the charge and the atom. So if you have 2 negative on one side, you have to have 2 negative on the other. And that's being reduced. You can see the charge going from 0 to -1, so it's going down. Now to balance this, notice you need 2 sodium atoms. So you have to put 2 in front of all the sodiums and the electrons, so the electrons cancel out. This is kind of why we do Hess's law before this, because the electrons will just cancel out, meaning there's 2 on one side and 2 on the other, and you get the overall reaction. Now this is a simple example, but you can see how electrons are transferring through the half reactions. Okay, so here we have iron. Iron starts at 0, goes to +2. That means there's 2 electrons being transferred. It's losing 2. It's oxidized. Now copper is gaining 2 because it's going from +2 to 0. So it gains electrons. And you can see the balanced reaction is already balanced because the charges are already balanced and the atoms are balanced. There's +2 on both sides, and there's 1 atom each on both sides. All right, so when do the half reactions, making sure that half reactions balance is when you have to have the charges are not the same number of electrons. So when electrons aren't being transferred equally, like a 1-to-1 ratio, you have to use coefficients to balance it out. So like in this example, you have copper with 2 electrons, and silver only have 1, so silver has to get multiplied by 2, and that's why I have 2 silvers on the product and reactant side. All right, so when do you need to add other aspects to half reactions? So sometimes half reactions aren't as equal, as nice as the previous examples, because oxygen is basically a definition of redox is that once you have oxygen on the side, you have to add water to the side that doesn't have oxygen. And then you have to have hydrogen on the other side, which is H+ on the other side. So in the basic definition of oxidation, you're going to have oxygen in these reactions. Some you don't, some you don't, but when you do, you have to add water, and then you have to add H+. So here is an example, a very typical example. You'll see this one many times, is the use of manganese 4 oxide. It's a typical oxidation agent, a very common one, very bright purple color. So here we have iodine. It is a charge of -1, and you are going to make I2, which has a charge of 0. So that means you need 2 electrons on the product side to balance out the charge. Because 2 negative is on the reactant side, that means 2 negative needs to be on the product side. Here we have manganese manganese 7, oxide. And since you have oxygen, water has to be added to the product side to balance out the oxygen, and then hydrogen has to be balanced on the reactant side to counterbalance the hydrogen from water. So to balance this, you need to balance the atoms first. So if you see there's 4 oxygens on the reactant side, you need 4 on the product side. Okay, now you have 8 hydrogens, so you need 8 H+. Okay, so all the atoms are balanced, but the charges are not. So you add up all the charges, you have -1 from the MnO4 and 8+ on the reactant side with hydrogen, so that's a total of 7 positive. And on the reactant side, you have a charge of +2. So it's not balanced. We need a difference between 5 So you need to add 5 electrons to the reactant side to make sure the balance of the reaction is complete with the charges. So again, MnO4 is -1, H plus, here's 8 of them, so it's 8 plus 8, that's a plus 7, and a 5 negative gives you plus 2 charge, and then the reactant product side is plus 2 as well. So iodine has to get multiplied by 5 to counterbalance the charges, and it gives you 10 electrons. Because the common multiple between 2 and 5 is 10, so we need to multiply the manganese side by 2. Everything gets multiplied by 2, so it's 2, 16, 10, 2, and 8. Now you can see that the electrons are going to be the same. There are 10 on the reactant side, 10 on the product side, so they're going to cancel out, and you get the overall reaction. So these, boom and boom, are gone because they're the same value, one on reactant, one on the product. So that's how you balance the half reactions when you have to add water and hydrogen. The main thing is once you see oxygen on one side, water has to be added, and then hydrogen has to be added to the other side. And then you have to make sure you balance it with the charges with electrons. So these are some half reactions. So this question you have to show the half reactions between chlorine and iodine, magnesium and oxygen, iron and oxygen. You can see the last one, or both second one and third one are going to have the same product on both half reactions. And then most importantly is the second question, you can show that how to balance the half reactions so that the electrons cancel out, and showing that what the zinc has to be multiplied by to get the electrons to cancel out, and what would be the overall reaction. All right, so not too bad. We'll practice more half reactions later, but let me know if you have any questions.